So we're going to take a look at lesson 2 practice questions. And we have for question 1 nitric acid. So you can take a look at your polyatomic ion chart and see what is the formula for nitric acid. And nitric acid is HNO3, and this is aqueous form. And it's going to combine with calcium hydroxide. So calcium has a +2, so this will be CaOH2 on the outside. And so what happens when you combine these, and I'm just going to break it down into its ions. So nitric acid is made up of H plus and nitrate, and calcium is Ca+2 and hydroxide ion. So the ones on the insides will combine and the ones on the outside will combine. And so what you get is calcium and nitrate, and the 2 will go down to the nitrate. So this will become calcium NO3. So we'll have to enclose these in brackets. And this will have the 2 here plus H2O. So let's just double check that everything is balanced here. And so I have to put the 2 in front of the nitric acid and 2 in front of water, and everything else now is balanced. So this is the molecular formula. Now we're going to take a look at the ionic formula here. So I'm just going to rewrite, put a line here. I'm going to rewrite what you have here. So the 2H, it will be 2 hydride aqueous. This is the ionic formula here. And nitrate has nitrate here, NO3 negative, and you also have 2 nitrate from our equation here. You have 1 calcium and 2 hydroxide, all aqueous. And what you get is calcium is going to dissolve Ca2 plus aqueous plus nitrate. You have 2 of those nitrate, and water. So water will form as H2O liquid, so that will stay as H2O. Now we know that this is aqueous because according to the solubility rules, calcium hydroxide is water soluble, so we break it down into calcium and hydroxide. Now we look at the net equation here, and we'll cancel what is similar on both the left and the right. So nitrate cancels each other out, calcium cancels each other out, so there is no reaction between nitrates and calcium. So what's left is 2H plus aqueous plus 2 hydroxide forming water. And again, balancing this, you should have 2 water molecules liquid here. And that is the those are the molecular, ionic, and net equations for the formation of nitric acid and calcium hydroxide. Now we take a look at the second one, phosphoric acid. So this forms between phosphate, look it up on the chart of polyatomic ion, and you will see that this is phosphate PO4 negative. And of course you have the hydride, that is the hydrogen that makes it acidic. Lithium is Li plus, hydroxide is negative. So again, the insides will combine, the hydrogen combines with this. Actually, I wrote the H plus first. And phosphoric acid is going to, the phosphate is going to combine with lithium here and form lithium phosphate. So this will be, let's write down the whole formula here. Because of the 3, that's going to go down to the hydrogen. So this is HPO4 brackets. The 3 will go down to the hydrogen here. So this is a triprotic or polyprotic acid. And lithium hydroxide is LiOH. These are both aqueous solutions. When they combine, you get lithium combining with phosphate. So the 3 here will go down to lithium. So lithium 3PO4. This is also aqueous plus water, which is liquid. Now just balancing everything here. I have 3 lithium on the product side, so I'll have to put 3 lithium on the reactant side, and water will have 3 coefficient in the front. So this is the molecular equation for phosphoric acid and lithium hydroxide. Now we started writing down the ions here. So for the ionic, you will get your hydrogen, and as you can see from the molecular balanced formula here, you have 3 hydride, and phosphorus here you only have 1, so leave it as just 1 there, no coefficient. Lithium is going to be lithium, so you have 3 of those, Li plus, and hydroxide you have 3 of them as well. And on the product side, lithium phosphate, again looking it up on the solubility chart, it is soluble. Phosphates are soluble combined with the group 1 metal. So this is going to break down 3 lithium aqueous. This is a plus, and phosphate, you only have 1 of those, aqueous plus 3H2O liquid. So we cancel what we can. Lithium will be canceled, phosphate will be canceled, and that brings us to the net equation of 3H plus aqueous plus 3 hydroxide aqueous forming 3H2O liquid. So that is the net equation for the combination of phosphoric acid and lithium hydroxide. Now let's take a look at the next question. Number 3. So we have sulfuric acid and aluminum hydroxide. So sulfuric acid is H2SO4. That would be aqueous. Aluminum hydroxide is AlOH. And this would be a charge of +3 for aluminum. I'm going to put the products on the bottom here. And a combination of these, you will get the H2 combining with the OH. That's the water part. And so I'm going to put H2O because that always produces liquid water. And the aluminum combines with sulfate. And you have sulfate is a -2. So you'll have Al2SO4. And because aluminum has a +3 charge, I will have to enclose that with brackets. So this is the molecular equation for the combination of these 2 compounds. The ionic, in terms of ions, we'll break it down into its ions now. So hydrogen, let's balance this first. So you have 2 aluminum here. I'm going to put 2 aluminum in front of the aluminum hydroxide, and that makes hydrogen. You have 3 times 2 for hydrogen is 6, and 2 here. So I'm going to need to balance hydrogen on this side as well. So I need to put 6 water. If I put 6 water here and 3 in the front, so that makes 3 times 2, 6 hydrogen. 6 hydrogen plus 3 times 2, so that's 12. 6 and 6 is 12. And you have 6 hydrogen here Let me double check here. That should be balanced. So 12 here, 12 hydrogen, 6 plus 6 is 12. So that is balanced. Okay, so that's the balanced equation. So here you have 4 hydrogen, H plus, you have 3 times 2, so that's 6 H plus. This is aqueous plus the sulfate, SO4. This is a 2 negative, and now you have 3 of those, aqueous. Aluminum, you have 2 aluminum plus 3 aqueous solution plus hydroxide, and you have 3 of those, and this is all aqueous. 6 water, and that stays 6 water liquid, and you have 2 aluminum here, 2 aluminum plus 3, and you have sulfate, SO4, 2 negative, and you have 3 of those, aqueous. Sulfates are soluble. Okay, so these are the ionic, and let's see what we can cancel. The aluminum cancels, the sulfate cancels, and so that brings us to the net equation of 6H plus aqueous plus 3 hydroxide aqueous, forming 6H2O liquid. It's the net formula for the combination of sulfuric acid and aluminum hydroxide. Again, you can use your polyatomic ion chart, which is at the back of your periodic table that I gave you in the beginning of the course. Okay, so let's take a look at number 4 now. This is not sulfuric acid, but sulfurous. Sulfurous is not SO4. This is SO3 negative 2. So this is a combination of S hydrogen. I'm going to break it down here. And SO3 negative 2. Magnesium is Mg plus 2. And hydroxide negative. It's sometimes easier to write down the ions that they form when they dissolve in or dissociate in water. So now that we can combine these ions to form the molecular formula. So I'm going to combine the insides here. But first I'm going to write down the reactants. So H2SO3 aqueous plus MgOH2 aqueous. And this will form, the insides will combine MgSO3 because it's a 2 and 2. There are no additional subscripts here. Plus water in liquid form. So look it up on the solubility chart and you'll know that sulfates are soluble. So this will be aqueous. So let's just balance the chemical equation here. And it looks like all I have to do is add the 2 here because now you have hydrogen 2 and 2 is 4. So I have to make hydrogen 4. And that's the molecular equation. So let's break it down into the ions. And so we have 2 hydrogens, so 2 hydride aqueous plus sulfate here by itself plus magnesium, which is a plus 2 aqueous, and 2 hydroxide, as you can see here in the subscript. And you have the 2 liquid water. Magnesium sulfate is aqueous, so it's going to dissolve in water. Mg2 plus aqueous plus SO3 2 negative aqueous. And let's just cancel the sulfurous acid here, sulfurous acid ion, magnesium goes away, and that brings us to the net equation of 2H plus aqueous plus 2 hydroxide aqueous, forming 2 liquid water. So again, those are just some examples of writing molecular, ionic, and net equations. So it always ends up to have the, if if you have a soluble compound in the product, and that will dissociate into its ions, and there's no reaction, it will not show in the reactions itself. So basically all you have that's left is water in a soluble compound. So you still have number 5 and number 6 here in the practice questions. And let's just finish this off actually. And I will move on before we move on to lesson 3. Okay, so this is nitrous acid, not nitric acid. So this is NO2 again. When you look it up on your polyatomic ion chart, this is NO2 -1. And barium, we know, is a alkaline earth, so it's +2. And hydroxide, as always, is -1. So let's combine the insides and then the outside. So for the molecular equation, you have barium will come first because it is a metal, and the 2 here will go down to the NO2, but they're both NO2 here is a -1, and barium is a +2. So actually, let's write down the formula here before we combine the molecular formula here. So nitrous acid is HNO2 aqueous plus barium hydroxide BaOH 2. They're both aqueous, and you have your water liquid plus barium and nitrate will combine, so BaNO2. I'm running out of room here, and 2. And this is aqueous when you check your solubility chart. So this is the molecular equation. I'm just going to balance this, and I should put the 2 here and 2 water molecules, and that would balance that. Take your time and check that it is balanced. You can always pause the video and check or balance it yourself. When you look at the ionic formula here, you notice that you have 2 hydrogen, so there will be 2 H plus aqueous plus NO2 negative aqueous plus barium plus 2 aqueous hydroxide. You have 2 of those. This is why it's important to balance your molecular formula before you go on to the ionic, so then you know how many of each ions you're going to form. You have 2 water molecules liquid and 1 barium aqueous plus NO2 aqueous, and you have 2 of these. And when you look at what's in common, that will cancel. Barium cancels as well, and it brings you to the net equation of 2H plus and 2 hydroxide forming 2H2O liquid. So what I'm going to do is I'm going to post the answer key on the Google Classroom, and you just have to try this on your own. So I want you to try number 6 on your own and check your answers on Google Classroom. It will be in the stream for today's class.